And we're live. Hi, everyone, and welcome back to the Observability and Security track. I'm here with Laurent Balmelii, and we're going to start with his talk on cloud delivered security for DevSecOps, making your DevOps process available anywhere and on any device. I'm looking forward to it. Have fun, man.
Okay, great. Thanks a lot. Let me share my screen, and thanks a lot for participating to this um, session. I'm going to share my screen. What I'll do today is also showing you a few demos and how that looks in real life. Because obviously it's not about presenting a technical topic, but it's also showing how that works in practice. I'm just going to introduce myself quickly. Um, so Today I'll talk about cloud delivery security for DevSecOps, and I think a lot of things have changed in the last few years, especially how people are working on development. People are working remotely, or having a completely distributed team that can be globally laid out. So I think there's a lot of things that we need to change also in the way we provide access to the DevOps process. And this is what I'm talking about because there's a few constraints that we need to deal with when we're doing that. So I'm just saying quickly about myself. You can find I have I think 27 or 28 publication on Medium. If you Google if you actually query my name on Medium, you find I have a few articles there that are mainly on security, but also on you know how this is connected to some also social issues, which I think I got a lot of interest in. I'm Swiss, actually French speaker, native French speaker, but I hope you can hear this from my accent. I grew up in Switzerland. Got my PhD from EPFL, École Polytechnique Fédérale in Lausanne, and but I lived most of my life abroad, mostly in the U.S. and in Japan. I worked at IBM, the research center in T.J. Watson in New York. That was for a few years there, and also did part of my PhD in the US before that, but like eventually graduated from EPFL. Um, I created a first company in 2013 that's named Strong Codes, which we're dealing with obfuscation, and so it's I don't expect people to know what's obfuscation, especially this is a DevOps conference, so it's just about protecting code running on devices such as like mobile devices, especially this is what we're focusing on. And eventually we got acquired by Snapchat in 2016 and stayed with them for 3 years, head of cybersecurity based in Switzerland. And after that, I came, you know, I wanted to go with a different venture, and I created Snow Network from 2016 to today. What I'm talking today here is mostly a technical topic, and I want to explain to you basically how you can provide access to a DevOps process in a very efficient way, and especially to be in control of your assets. And the assets here in questions are source code, data, credentials, everything that you need basically to provide access to your process and so on. There's a few articles I think they're interesting that I want to mention here. Uh, this trend of the digital nomad that you can see this in Forbes. There's an interesting article here, how people basically are working remotely and getting access basically to potentially corporate data that shouldn't be accessed from a location where you don't really have control on first on the device of the machine, the device of the developer, and some other parameters. Because people might access your data from a network that should be assumed to be compromised, or could simply lose his laptop, right, or lose his data and lose your data, and it could be anywhere. So you want to be able to be in control of this. So uh, we need to adapt to this trend. And for that matter, actually, I wrote that article called the Trust the Liquid Workforce. This liquid workforce concept came from I think it was an Accenture vision document that these companies they every few years they come up with a vision document. Now, what's the future of some trends in the IT space and other technological domains. And the liquid workforce, this concept that basically today companies, they have like developers that they can scale in, scale out the number of developers that they need for certain project. They hire people on project. There's also all this trend of this, I'm sure you're aware of TopTal, Fibers, all these companies basically that provide an outlet for freelancers to be involved in the workforce in a very flexible way, right? But also you have to trust the liquid workforce, because if you start working with a lot of people and you don't really have an efficient way to vet them, also to and you're going to share your intellectual property, you want to make sure that things are going well. I've wrote an article here about that problem here on Medium. You're welcome to take a look. So what are the problems that a global DevOps process have to tackle simultaneously in order to to become global, right? So the key problem here is to provide IT infrastructure for code development in an efficient way, right? And what I mean by that, is to provide access to an environment for these developers to develop, access to a way basically to test what they do, deploy things that they do, and we know a lot of things in DevOps. I'll mention obviously some key books here after that, but a lot of practices that made the process very efficient. There's like a few principles. I'm not going to go over these principles in detail here, but a few principles that DevOps that I'm sure most of people in this conversation attending my presentation know very well. So I'm not going to repeat these things, but so you're all aware that there's really three things that we need to do efficiently. Is that first we need to maintain cost effectively all the infrastructure that we provide for our developers and especially people working on operations, deploying the applications and monitoring the application, all those things. Then we need also to provide security, and security in DevOps is extremely complex. I mean, there's really many facets. Here I'm going to talk about mainly asset security, data security. So how you make sure you protect your source code, your data, and also your credentials, all the credentials basically that people will use to connect to applications that you need. Could be applications like GitLab, GitHub, Bitbucket, GR Confluence, you name it. All this application, they require obviously credentials, and you need basically to have a means for providing this credential to your developers, and you won't have control over all this information, right? And last but not least, I think it's very important that we also need to foster collaboration, because especially if you have a distributed process and people will work from their home or from a remote office, you need to make sure that they can collaborate efficiently, right? And in the world today, because we're highly connected, there are many ways actually to have very efficient ways to collaborate, and we'll look at these things in detail. So first of all, let's look at a few components for IT efficiency. So first of all, I wanted to mention one of my favorite books on DevOps. I'm sure you all know it, but I think it's a good reminder. It's kind of a thick book, with 200 plus pages, and but I think it brings down all the key concepts of DevOps, and especially what you need to implement in your process in order to be highly efficient. And all this principle, they're not necessarily theoretical, they're more academic way. They present it in an academic way here inside the in this book, but like they also explain a very efficient ways to implement them in your process. So here I will just recall definition: DevOps is general development methodology applied to creation product and services. And you all know this is not only for software applications, but it can actually be also applied to very different things. I'm not going to go in detail here, but very different things. And the general mantra of DevOps is how to involve technologies to deliver better results by reducing the gap between development, creating things, and operation, using these things in production. This is why we contracted these two words, dev and development and operation, DevOps, in order to reduce the gap between development and operations. So this is the basic. So one of the first components that recently took over DevOps, and it's actually something perhaps the most efficient way to tackle some of the key issues when you run a DevOps process is the containers. So I just wanted to remind people here in the conversation what containers are. I'm sure you're all highly aware of what containers are. Mostly you're using most of this things, most of the containers in your current process. And so the foundation for DevOps collaboration, they help isolate application with the libraries and dependencies. So I think not using containers today would be a mistake, because it will really make your DevOps process much more modular, efficient, and you'll be able to isolate issues, right? And this is because of you can really completely insulate applications from all the dependencies and things that they need to run. There's a good article here from Microsoft that you can take a look. Containers are the foundation of DevOps collaboration. Containers will help you to develop and design efficiently. A container, interestingly, it's based on an OS, so you'll have a Ubuntu-based container. It's not necessarily, but the one we use often is based on an OS. Could be anything that you need, but it can really, in a sense, replace a machine for development. Right? This is really the goal here. You can develop directly inside the container. This is the key thing. And that's why you have this. It's actually very easy, basically, to use them to build, test, ship things. You can duplicate containers. You can give access to other people for collaboration. I mean, you can do many things to containers that are very efficient that you would do. It's much difficult to achieve with obviously a local machine, but even with a virtual machine, right? Because this container is much more efficient and compact. And last but not least, you can directly deploy based on containers, and it's easier basically to manage and monitor your process once the application is online. So that's the first thing. And the second thing I'd like to introduce, because it's part of this way to make your process efficiently available anywhere, is cloud IDEs. So I don't know if you ever use a cloud IDE, but actually you might have used a cloud IDE without knowing it, right? Because they actually some IDEs, and one of them is Visual Studio Code, that is implemented in a way that they can run directly in a browser. So from an implementation perspective, VS Code was implemented in TypeScript, and this is something that allows you, technically speaking, to execute this IDE directly in a browser. So it's whether you install VS Code locally or using in a browser, it's actually 100% the same code. But obviously, using in a browser has many advantages that I will go over in a few minutes, but it's exactly the same environment. So a cloud IDE is simply when the execution environment is actually your browser. Your browser, it could be Safari, Chrome, or Edge, and this is mostly Chrome-based browser, but you can run this pretty much in all the browsers here. And the advantage of using a cloud IDE, again, is that technically speaking, is the same IDE that you would have if you execute locally, at least for the ones that are implemented in a way that they allow this. So VS Code is one of them. Jupyter is another one. If you use JetBrains, there's something called Projector that actually can fake that thing. It actually make it look like it's a cloud IDE because it's a way basically to render thing in the browser. The whole JetBrains could be IntelliJ, for instance, could be used in the browser using Projector. It's actually an open source extension to this. So the advantage of using, think first, what stays the same, right? So whether you use a local or the Cloud IDE version of your VS Code, it's actually the same execution. It's still a local IDE execution because the TypeScript code will execute in your browser like it will be executed on your computer. It's just a thing. It's just executed in a different environment, but it stays, technically speaking, it stays local execution. You see, have access to the marketplace, could be free of commercial. This is something that is also something that would. What changes is that it allows you to work in a container directly. So if you take a Cloud IDE package, and there's several here, I'm not going to go into detail, but it allows you to work directly from a container. And this container can be local on your machine, but it also can be remote. So I'll talk actually in mostly of the case when it's remote. And this is something, because it has a lot of advantages, right? So the benefits is that first, it will provide access to fully installed environment anywhere, because your container has this fully installed environment. You can provide a container that has everything that your developer needs to work. And this is something that will ease a lot the deployment of giving access to a fully installed machine. The person will not have to make most of the installation of this machine. He might want to configure to finely tune that machine for his own benefits. Perhaps favorite libraries, favorite tools, but like you can ease a lot of the work by providing a container to start working, right? And IT efficiency, you can switch project by just switching container, right? It's very easy because you can have containers that just fit for a specific project, and that will be. So the Cloud ID is the second way to make this efficient. So if you haven't seen a Cloud ID so far, I could just show you what it looks like here. So this is the platform that we have, a strong network, but you can use another one here. So basically, when you log in on your platform, this is the screen you get. And instead of starting, so this is a Chromebook, by the way, I'm actually working on a Chromebook. You can see instead of, I cannot install thing on a Chromebook, so I could not, install VS Code on my Chromebook. But the thing is that I would, instead of starting my ID from my icon bar, I start it from here, and this is it. And this is your ID that's coming directly in your browser. You see this actually, see a URL here. You can get rid of it because you can actually really install your thing. And then this is what's happening. And you can start working here. And this is actually a view inside your container. This is a Linux container, and there you go. And this is Linux, and this is like actually, but this actually container is not running on my machine. It's actually running on a remote server, and this is giving access. So this is basically what a Cloud ID allows you to do. So this is the first step for having inefficient components. So the next step here, once you have this, let me just go back to full screen here. So what do we do by providing Cloud IDEs and working containers that remotely deployed? Is that this is our usual DevOps process here, and this part of coding that you know very well here is that you used to do on a local laptop by having things installed locally in the laptop. This is actually becoming also part of your cloud infrastructure, right? So whichever Cloud IDE provider you use, this is becoming part of your cloud infrastructure. And then basically the rest of your process is already all in the cloud, right? You very likely use GitHub or GitLab or any provider for Git applications here. You can build in the cloud, you can test, you can release, and so on. So basically what getting this Cloud IDE and container-based development solution allows you to do is basically to put this part here of the DevOps process here in the cloud, which is very efficient because then there's going to be a lot of advantages for bandwidth, for connectivity that basically you don't have if you work locally. And I think this is kind of the last step before having a fully cloud-based process for development. And obviously it has the advantage to provide very extensive connectivity to your process, regardless of the location of your coders. So what do people get access to when have this? This is two pictures what's happening. And what I just show you in the demo, the example is that people get access to a development machine here. It's a VS Code, JetBrains, or Terminal. You can also Terminal for Emacs and Vim. And basically what's happening is that your developer would just use his browser. So it could be any machine, because since you actually only get access to the environment from the browser, you don't need to have this OS-specific machine, especially you don't have to install OS-specific libraries. So whether that developers use Windows, Mac, or Chromebook, I'm using a Chromebook at this time here, it doesn't make any difference for you, because what happens is that he will open this environment directly from his browser, connect remotely to the machine you give him access, the container. This is the container here, so that's why you have the Docker logo here. And it will be a Ubuntu Linux, it could be a Fedora, it could be anything you need. And basically what happens here is that all your code and all the work that is done is actually done directly in the container and is not landing, technically speaking, on the laptop. So one of the first benefits also, you have all your data will stay directly in your cloud, will stay basically on the cloud where you deployed your cloud IDE. So this is a way to get an efficient process. Obviously, in this case, we need to be cognizant of what kind of application we can develop with this. So, what kind of application can I develop? Well, it's everything that is web-based, right? It's everything that is web-based. When you work on web applications, when you work on also mobile applications, this is something that is efficient, right? I can explain to you, this is not the point of the discussion today, how you develop mobile application in this setting, but it's very you can even test locally your mobile application by connecting your phone to your machine. But obviously, you have to do some trickeries that I won't go in detail for that today. But obviously, it's super useful to develop web application. And containers today, they're mostly Linux, but you have also Windows containers now that exist, and you can also do web-based development under Windows. But here I will skip. I was keep to Linux distributions. So that's the first thing. The first set of components for IT efficiency you can consider in the DevOps process is to let's use containers because they're useful. They allow you to isolate issues, and let's use cloud IDEs because they give this uniform access to a process that would not depend on the device that the developer is using, will not depend on the OS this person is using. The only thing that you technically need is a device with a browser, and you can access your DevOps process. You will have an IDE, and you will connect to a container that actually is still in your cloud. But now, this is the second point I wanted to address here. What about security, right? How can we ensure in that kind of setting security? Because the point here is that where if you're gonna hire people worldwide and you might have never met these people in person, it's good basically to maintain a certain control what's happening to your data. So one of the things I found interesting here, and it's basically using the NIST 800-207, which is the specification for what is referred to as zero trust architecture. And this is something that could be used really to your benefit in order to have a consistent way to connect all the different resources that you would have to use in your process, in your DevOps process, right? And this could be, there's actually 3 types of resources I want to mention here. I put the link here to the specification of NIST, so you're welcome to take a look at this. I also put here a link to, this is a Medium article that I wrote that explains basically very simply what zero trust is, and also what you can achieve with basically what's especially the demise of the IT perimeter. I think this is one of the the tenets of zero trust, is that it allows you to go beyond I think it's explained simply, and according to Medium, it's 11-minute read. So I hope you have 11 minutes and you can take a look at this. So it's behind the paywall. So if you get like run out of quota for your Medium articles, just send me an email. I can send you a friend link, and you can open that article for free. There you go. So what do we do with zero trust, right? We have 3 types of resources we'd like to connect in your process. And the first type of resources is self-hosted resources, which often some company would have some of their services self-hosted for just practical reasons. It could be like your API that you're testing, or it could be an SSH machine. It can be also TCP services, right? Because lots of industries are still using mostly TCP-based services. They think of like Oracle, JDBC, IBM Kix, and all things. Lots of people actually using databases based on these implementations. Privately hosted resources, you can host privately resources in your cloud. If you have access to GCP, if you have access to AWS, a lot of privately hosted resources. You have your own Git application deployed there. You have also your data buckets very useful today. Data buckets, we can do lots of things with that. But obviously, a lot of people have publicly hosted resources on GitLab.com, GitHub.com, and other services that are public services that you can easily adopt, just by creating an account. So this is typically the three types of resources that we'd like to, and the goal here is to have a way to manage interaction between your developers and your workforce and these services, right? The zero trust architecture here is really an access control method, right? And if you read the article that I refer here, it's all about access control and microsegmentation. So microsegmentation is just a way to control who accesses to what in which context, right? So there's many ways to implement this, but I wanted just to lay out the principle here. This is really something that you should consider when you implement things. There's different ways to implement zero trust, but this is something that you need to consider when you want it, because it will basically give you access to your resources in a very efficient way and also in a controlled way. So I think this is one of the first things that needs to be established. And once you have this, created that ZTA around your resources here, then the goal here is basically to deploy these IDEs here. The thing that I mentioned before. So there's a conjunction of the IDE with a container, and also you likely also will need a browser to access like applications, because you don't want only to control access from the IDE to these services, access, for instance, from the IDE to an API, SSH machine, your privately hosted Git application or data buckets. We also want to control access to your public applications, right? So basically, you would ideally broker the access to your Git or your GitLab from a browser that will be fit for that, right? And ideally, what you would use, and I'll get a bit to detail later on that, you want to SSO. You have to have a single sign-on method to go through basically your architectures. You can control who accessing which of your resources, right? I think obviously you could say, yeah, people can access independently my resource. They don't need to go through my infrastructure to access my resources. You can just give them, they just go on gitlab.com and they just enter the credentials. But then the issue, if you do this, is that you don't have control of what they do, right, on your repo, right? And it's just something that you don't want them to do, and it's difficult. This actually, GitLab and GitHub are collaboration tools, right? They're not security tools. So it's this actually limited things that you can do in order to monitor access and to make sure that people use these resources according to your company policy, right? So I think this is one of the things you need to be worried about. So way to control credentials is to have a single sign-on method to go to this. But obviously, if you don't have, how do you put basically developers that are remote or globally distributed onto your single sign-on thing? I mean, it's just ways to do this, but it's something you have to keep in mind that it's something that you have to have under control. But the goal here is that once you have this infrastructure in place, you can actually create on demand at will all these environments and send this to your developers so they will have access to the environment. And remember that one of the key aspects here is that the containers into which they will develop your application will actually be deployed somewhere in your cloud. So they don't have this data locally. Everything is efficient. And if you need, for instance, to update some of these containers, it's a few clicks, right? You don't want to basically have people do not need to maintain at least in an explicit way the platform, the container into which they work. So this is very efficient. People can switch container. You can duplicate machines, which is one of the tenets of DevOps, is that for testing, you want to be able to duplicate environments, able to share environments efficiently and all those things. Just one word, I don't want to be too technical today. One word about ZTA and what it offers is that you can obtain multiple level of segmentation for your network. So let's say if here you actually access to your resources here, You can have different level of what it calls microsegmentation that would be very important. You can level 1, you would say, I want to make sure that developers, they really use my IDE and their container to access my resources. I don't want them to be able to access my resource outside the scope of my container, right? So this is guarantee that people use access to your resource, could be data, could be credentials, could be especially source code, only from their agreed environment. So this is something you can guarantee. So they don't use like the different laptop, they use their own laptop, they use their own, I would say like, they might work on BYOD, but like they can use a different environment that that's not under your control to access your resources. That's the first thing. Second, you can force people to use a certain protocol. So it can be SSH, be HTTPS, but if you use protocol, you basically have a certain guarantee that if they use SSH, that you'll be able to control the keys for this. And one of the important things is that for an organization, that to be in control of all the private keys that are used to access your repositories, right? And if you're in control of this, you're in control, of access to your your data source code. It could be anything that will be access to SSH, right? It can be a machine, also services, machines, and so on. So it's important actually, if you control the protocol, you can also control the keys, and you have a way basically to manage all these keys, and there's different mechanism for this, but you want to be in control of the keys, right? And also you want to be in control of, it could be a specific domain where people access the Git repository. So you can also whitelist domain names, so they cannot basically access repository that you don't want to access. For instance, the one that will be in control, they can make a copy of your code, for instance, something that they control. And last but not least, I think this is a bit involved today for the discussion. It's called, we call this narrow radius. You can, instead of giving, and just give you the gist about this, instead of giving access to the entire Git application, you can give very often access to a single repository, right? So I think this could be very efficient, because instead of giving access to the entire Git application, where you will have to make sure permissions are set up correctly, so you can actually restrict access to a single project, a single repo, using permission of the Git application. But what if it's misconfigured, right? So one of the things. So there's also another way to do this, is using keys that will only give access to a single application. I think most of the public services, they allow to do this type of things, like GitLab allows it, GitHub allows it. I'm not sure Bitbucket. I think the Bitbucket doesn't have that capability, but I know that GitLab and GitHub has it. So it can be very efficient, because if you can force people only to access to the specific repo, then it's efficient, right? I just wanted to put this thing to compare this to what VDI, if you know, virtual desktop infrastructure, would provide, because some people, in the audience might actually compare this remote access as a VDI. I think it's a good comparison, but also it's not the right one, because VDI are completely different in nature. A lot of VDIs are used for back office access to back office applications. When there's actually an issue with data. I don't think VDI is very popular with developers, especially that because of this remote desktop protocol, things that will might actually impede your experience, hinder experience when you work on development. So the advantage is that by using cloud IDEs, we have local clients. There's no video, so it works on low bandwidth. You don't need to have bandwidth. If you're like in a remote location, actually you can run this on your phone. It works very well. Works everywhere, no developer discomfort. VDI is not, at least at the onset, not based on software. You can obviously do some packet deployment, but it's not the main purpose. First purpose is just to provide access to a machine remotely. You can integrate easily zero trust as an infrastructure here to control your keys and have different level of microsegmentation. This is something that will not come for free on the VDI. That will likely be an addition layer on top of it. You can single sign-on to data resources. Again, for the VDI, you would have to put this in plus. This is actually quite easy to do on a Cloud ID infrastructure to do that. And you can have full data prevention, not only clipboard and all things, but you can also control the network, which again, on the VDI setup, you would have to add this on top of the core function, right? Just wanted to put this. So the last thing, I want to mention to you is that once we have the IT efficiency in place, once we have the security in place, we want to do collaboration, right? Because collaboration obviously is something that is, will foster productivity in your team, and you will make sure that you put in place a highly collaborative infrastructure. So here, first of all, one of the advantages of putting this type of mechanism in place is that, I mentioned this before, you can work on local ID clients and remote. So you have local ID clients for comfort, and you have remote organizational data because the container stays in your cloud. The second thing you have here is that you have device OS independence, and this is efficient because you don't have to be in control of what kind of device your developer will use, and you can use actually any device. And some of the actually in our team we only use Chromebooks, and I think this is something that is very efficient for development because it's also from a security perspective it's also much better. Also, you can instantly clone template infrastructure, create copies of your environments, of your containers, and so on. So I think this is thing, and you can get real-time collaboration metrics. I have a chat on this at the end of this presentation here. So this is one thing here, and then you can get access to external app service from anywhere, and so on. I think also something that is important for collaboration is that you want to have a faster than local development environment. I think one of the advantages when you have the entire DevOps process in the cloud, including the code part, right? You remember that infinity sign that I showed before. Even if the code stage, when this code stage is also in the cloud completely, and again, I mean, by being in the cloud, that means your container execute somewhere in your cloud and people just access the container remotely and from a locally executed IDE. You get basically the best of both worlds, right? You get better connectivity, but also you have faster than local development environment because everything now that connects to your network, like when you do a Docker pull, you do all those things here. This is something that will directly leverage the bandwidth of your cloud infrastructure, so it's much faster. You can also co-edit source code. Is something that I don't know if you've seen that. Some IDEs now provide this type of things, but because people are connected to the same cluster, actually, the way we deploy, I haven't gone into detail for this, but like the way we deploy this containers using a Kubernetes application. I think it's the easiest way basically to control your containers. You're all aware of this. You can actually do things that are interesting. You can actually go and work two people in the same IDE and co-edit things. And also you can share local running apps with Airbnb Online. This is kind of the advantage to be all connected is that you can do things that you wouldn't do able. It will be much difficult to do it if you locally. This is just a thing of real-time performance that you can get when people are working, but I want to just show you, complete this thing here by showing you a quick demo of what could be collaboration in a purely connected world when you use a Cloud IDE. So let me open here my Cloud IDE here. This is my environment. So what I'm going to do here is that I'm going to start here. I'm going to start an application. So this is this environment. I'm going to start an application locally on my machine here. So this is my container in the cloud here. I'm running an application here on localhost 8866, but actually you see it's not really anymore localhost because localhost doesn't really exist because the localhost is directly in the cloud. It's not really local. What's going to happen here is that I have this application here running on my here. This is the application running on my workspace. But what I can do, this is one of the magic you can do. I'm just going to check that this application actually shared with here. There you go. And I have this application here running here. So what you can do here, if I go into the chat, I can actually share that link here. And you will be able to, if you go on the chat, you click on this link, you'll be able to see my application running on my workspace directly on your machine, right? This is kind of the magic of when everything is connected, is that you can do this type of things, is that you can actually share a running application, with anybody in the planet, as long as you made it public, and this is what so I could basically, do this. This kind of magic you can do. So if we look at my IDE here, and There you go. The application will be running here. And sorry, I just lost my screen. Okay, the application here will be running, and you should be able to open it on your thing. So this is it. I think this is what I wanted to finish. I think we have about 10 minutes for questions and so on. There's also a quick video here that I share with some of the participants. I put here when working around the globe. IT efficiency is a prerequisite, security is a survival skill, and collaboration will save it all. You can look at this video if you see the principle that I think is working. If you have any technical questions, you're welcome to contact me, and I can give you more technical details, how that works. But I think this is perhaps one of the efficient ways to make your DevOps process available anywhere and on any machines. That's it. So I don't know if we want to go to questions. I think we have 10 minutes, right? I cannot hear you. Yeah, perhaps I can hear you now.
It might have been my microphone.
Yeah, now I can hear you. Fantastic. Sorry about that.
No worries, no worries.
We have 10 minutes for questions. Is that correct?
We have about 3 actually.
Oh, okay. Sorry about that. I felt like we were finishing at 5:02. 3 minutes for questions. Okay.
Yeah,
so
no
anyway, feel free to send me like an email with your questions.
How long have you been working on a cloud ID? Because I'm assuming you do that daily, no?
Yeah, so exactly. So the entire team works on Cloud IDE, and we've been doing since the beginning. We just started on this. We didn't never look back. Yeah. And I think it's really. I think it makes us like much more agile, much faster, and also we don't really need to situations where we have some things. Oh, it doesn't work on my machine. It works on my machine. And stuff like that. So this is one of the key things, but also for deployment, for debugging. I think there's a lot of advantages for doing that. But I think it's mostly the fact that coding directly in containers, I think is super efficient, and it makes really the thing. But I think we'll focus. I mean, my background in cybersecurity, the focus was mostly basically to provide some reasonable security when you provide access remotely to a team, which is just sanity, right? It's just like to make sure you have like a good housekeeping.
Yeah.
And So that's why I think a zero trust thing is interesting, zero trust infrastructure is interesting. If you read the specification of NIST, there's a lot of ways to implement this, and we are our own. But actually, I invite people to look at the Medium article that I wrote on that, and contact me if you have any questions.
Yeah, I think I'm going to check it out. What I was thinking, because I give a lot of trainings, and on those trainings, like we have to, for example, one of them is on fundamentals in Go. So you have to install Go on your machine, and it's different from Mac than on Windows. And we've tried like a virtual environment, but it's not exactly the same.
No, it's not. The advantage I was mentioning that it's not a virtual machine, right? I mean, it's actually a container. Technically speaking, it's a container executing on a virtual machine, but you don't have all the disadvantages of virtual machine. You just have the advantage of the container, which I think makes the thing very efficient. Yeah, so I think it's an efficient way to use. I think this, especially when you provide training on this, I think is a good way to save all that time when you have to set up the environment and configure things.
Yeah, I think I'm going to try that out. One of the challenges there was then that, I mean, they need to connect to GitHub for a repo. So then within that container, they need access to probably their GitHub credentials in some way. Is that possible as well?
Yeah, exactly. So this is something that we implemented. We have full SSO from this, because this doesn't come. This is a feature that we implemented, is that we can basically access. We manage all the credentials from this container. So we also give you like a safe access to all your applications. Yeah. So you don't need to explicitly share credentials with people you work remotely, and they will have basically access to exactly what you give them access to, but they would not know the credentials. They cannot circumvent your platform. They would have access to your stuff, and they cannot just go around your back and say, hey, just me use that credential for doing my own stuff. And it really saves you a lot of headaches, I guess.
Yeah, perfect. So I think that's it with regards to time. Thanks again, Laurent, for the talk. I thought it was very interesting.
Thank you. Thanks.
If you guys want to check him out, Laurent Balmelii You'll probably find him in the speaker's overview. All his socials will be in there. So check him out.
All right.
And that's it for this session. Thanks again.
All right. Thanks,
See you
guys.
in the
Have a
next
good
one.
day. Thank you. Bye.
So now's my countdown for this stream to end. I think everyone sees that.
Fantastic. Yeah.
Yeah.
All right. Have a good day, man. Bye.